SKnow is an IoT platform developed to aid managers to monitor and control winter sport complexes. Using HTTP and MQTT protocols, it implements the IoT paradigm to provide a reliable and performing environment. The system allows users to integrate a fleet of smart snow cannons alongside a set of heterogeneous sensors in green, the measurements of which are processed by the data processing services in red, and the user's interfaces, website and Telegram bot in yellow provide real-time data visualization and complete manual management on the snow cannons, while the automation services in blue optimize the cannon's schedules based on the personalized strategies and manage the notification of alerts to users. The service catalog allows the reciprocal discovery of the system's services by managing a JSON file containing an up-to-date detailed list of all working microservices. All services periodically contact the service catalog through its REST interface to make themselves discoverable and keep their information, such as IP addresses, up to date. Similarly to how the service catalog keeps track of the exposes the system services, the resource catalog makes devices such as snow cannons and sensors accessible and discoverable by the system services. It manages different JSON files, one for each winter sport complex, and each file contains a hierarchical view of the facilities, many localities populated by slopes, each divided into sectors. All running devices periodically sense their information, including their positioning, in the complex using the resource catalog's REST interface.
The login service provides token authentication for the users when accessing the SKnow website or Telegram bot, fit in the management of the facilities. All the REST requests that the website and the bot send to the resource catalog are first run through the login service to check token integrity and grant data privacy against requests from unauthorized users. SKnow cannons and sensors, although not microservices, are part of the SKnow ecosystem as they represent the interaction with the real world. SKnow cannons are actuators waiting for commands to an MQTT subscription. The subscription topic considers both the individual cannon's ID and its position inside the winter sport complex, so that it can receive status changes both exclusively or as part of decisions on a bigger area of interest. A SKnow cannon can be set in manual mode, controlled by the Telegram bot, automatic mode, based on the surrounding snow level, or in programmed mode, based on the current time. Sensors, on the other hand, perform measurements and publish it on an MQTT topic. Environmental-related sensors, such as the one measuring snow depth, temperature, or humidity, publish to a topic related solely to their position inside the complex. The ones linked to a specific cannon, as is the case for the water level sensors, instead include in the topic also the cannon ID.
The automatic power-on control offers automation capabilities and is in charge of periodically checking the settings related to every SKnow cannon and turn it on or off accordingly. If a cannon is set in automatic mode, the microservice will retrieve the last snow level measurements related to the cannon slope sector from TeamSpeak. If it is below a user-provided threshold, the cannon is turned on via an MQTT message. If instead the cannon is in programmed mode, the microservice checks the current time and turns on the cannon if it is inside the cannon's programmed time range. The water level control manages alerts related to low levels of water in the cannon's tank. It periodically checks the water level from resource catalog for each cannon. If it is below 20%, it publishes a message to an MQTT topic, which is listened to by the Telegram bot, which consequently sends an alert to all the chats associated to the account managing that cannon. The data manager is in charge of receiving measurement data via MQTT from the sensor and dispatch it to the right microservices. Currently, water level measurements are sent via MQTT to the concerned cannon, while environmental data are provided to the TeamSpeak connector with a REST POST request. The data manager's loose coupling allows the future integration of any other database and visualization tool. The TeamSpeak connector allows for easy TeamSpeak channel management and data sending and retrieval. This allows modularity and separation of concerns. The microservice formats the received REST request in the right format required by TeamSpeak.
The SKnow website is the first of the two user interfaces in which SKnow clients can interact with the system. After the token authentication, the user can manage the winter sport complex at high level by describing the structure of the facilities. It is possible to add or remove localities, the slope inside, and even the sectors composing each slope. When a sector is created or deleted, it is linked to a TeamSpeak channel for storing data from its sensors. After selecting a sector, the page provides real-time data in the form of last retrieved measurements and/or a historical collection. All the data are retrieved from TeamSpeak and the graphs can be personalized using different time filters. The Telegram bot is a more flexible everyday usage user interface, which provides direct management of the SKnow cannons. After the token login, the user can navigate up and down the winter sport complex a hierarchy of localities, slope, sectors, and cannons, and perform actions at the chosen level. One of those actions is the visualization of the network, along with information and statuses of the cannons and sensors. The user is also able to turn on and off the cannons, put them in an automatic or programmed mode, and even set a threshold or time range for those two modes respectively. For quality of service reasons, the user is also given the chance to toggle the water level notification and to log out of its account.